Welcome you all students in this class. During previous class, we have studied about thermometric type of substance and we have discussed about upper and lower fixed point. Now, during this class, we are extending our topics for the next one. This is the types of temperature scale. So there are three types of temperature scales. Number one is Celsius scale, also called the centigrade scale. About 200 years ago, Mr. Anders Celsius selected two fixed points, namely ice point and the steam point. Now, this is basically the main point here. This one is the ice point and this one is steam point. Putting at 0 degrees Celsius, which is the lower fixed point, and putting in the steam, when it reaches temperature, it is up to 100 degrees Celsius and it becomes stable or the stops, that is the steam point, and this one is ice point. Now the ice point in the temperature of a pure melting ice at standard atmospheric pressure is 0 degrees Celsius. But the steam point is the temperature of the steam standard atmospheric pressure, that is 100 degrees Celsius. 100 degrees Celsius temperature, there is no more increase in the temperature. This is upper fixed point. We fill the mercury inside thermometer and then we place it inside a liquid melted water where its temperature is 0 or the lower fixed point of the ice, that is 0. We mark it 0. Then we place it into steam. The temperature, the level of the mercury starts rising. It reaches up to a point and becomes stops there. So that point is marked to be 100 degrees Celsius. And these are the 2 points which were defined by Celsius. Now Fahrenheit. Fahrenheit scale was introduced by Fahrenheit with the name of a scientist. On this scale, the interval between lower and fixed points is equally divided into 100 equal divisions. The lower fixed point is 32 degree Fahrenheit and the upper fixed point is 202. And in between two equally 100 divided into 100 equal parts. So one part is equal to 1 Fahrenheit. So this is the main in case of Fahrenheit. Lower fixed point, that is 32 degree, and upper fixed point is 212 degree. So the third one is Kelvin. This scale was introduced by Lord Kelvin. So this is the person who is responsible to introduce this type of scale. He named the scale as absolute scale. The lower fixed point he used is that is 273K and the upper point is 373K. You'll see every type of the scale has equal 100 parts. Either it's starting from 32 to ending up 212, or it starts lower fixed point that is 273 to 373 Kelvin. The internal between these two fixed point is divided into 100 equal parts. 100 equal parts are the divisions, and each division is 1K Kelvin temperature. The zero on this scale is called absolute zero, and this absolute zero is basically minus 273 degrees Celsius, and we will see what the absolute zero is during our next slides. So lower fixed point is basically at 0, and 0 is basically minus 273 degree. So minus 273 Kelvin. We can't write over it Kelvin because it's SI unit. So here it is. The temperature at which the particles have slowed down so much that they no longer possess any kinetic energy. Kinetic energy, that is called absolute zero. What happens? We take this type of the scale and we draw the line. Along this line there is minus 273 minus 273 temperature, and here it is plus 273, which we take 273. Here its volume. So it is 273. It's 273, and we have drawn a line between the two. I am going to explain what the minus 273 means, what it means minus 273. Is it possible? Theoretically, it's possible. Practically, it's not. What happened? You draw temperature along x-axis and volume on y-axis, and you see you starts increasing the temperature of the gas. It starts its volume increases the increase of the temperature. So you will be getting a straight line, this one. And if you see that this is a straight line, these results are obtained practically. If theoretically you extend this line to the other side, it goes back and it reaches at a point to the other side, to the negative side of the temperature, that is minus 273. Practically, you have performed this experiment. But theoretically, you see, if you have extended to the negative side, this shows that this will be the temperature, this one minus 273. Here, if you look at the value of volume will be zero. What it means? Is it possible that the gases are there and their volume is zero? No. So then, what's the reason? What's the logic? Logic is that when we start heating, the expansion takes place. The separation between the gases increases, which results in increase in the volume of the substance. But similar, what happens if we do the reverse process, cooling process? By cooling process, basically we start to reduce the vibration or the motion of the gas molecule. Our time reaches where the kinetic energy is zero. Their vibrational motion or any type of motion becomes eased. At that time, the gases have the minimum type of the volume, and that volume is said to be, at that time, the temperature will be called absolute zero, at which the gas molecules freezes. So minimum volume, it's not zero, it's minimum volume. This temperature 273 is called absolute zero. Again, I'm repeating. What happens if you start increasing the temperature of the gas, the volume of the gas molecule will increase. So what will happen if you do the reverse process? Their motion will decrease, 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 and decrease. What will happen at the end? Their motion stops, ceases. And what will be the volume at that time? Minimum, that is closer to zero. This temperature is called minus 273. So comparing temperature scales, these are all temperature scale listed. Number one, if you look at, this is the freezing point that is 0 degrees Celsius, and it is 273 K, and it is 32 degree Fahrenheit in case of Fahrenheit scale. But what about the boiling of the upper? Basically, this is the lower freezing point, lower fixed point. This one is the upper fixed point. Here, it's 100 degrees Celsius, boiling point of the water. It's in Kelvin, it's 373 K. And in case of Fahrenheit, it's 212 Fahrenheit. And when you are asked to convert, if you are asked your body temperature is 37 degrees Celsius, find out this temperature in Fahrenheit, you will use this formula. You will put the value of 37 here. You will do some mathematical steps, and then you will be able to calculate your body temperature in Fahrenheit. But if your body temperature is 37 degrees Celsius, you are asked to calculate in Kelvin. You will put the value 37 here. You will add these two. Finally, you will be getting temperature in Kelvin. So these are some techniques to convert one type of temperature, one scale temperature into other scale. For this, you must know what's the formula. This formula is used to convert temperature of your body in Fahrenheit to centigrade. This is the temperature scale which is used to convert your centigrade Celsius temperature into Kelvin. So here it is. If you look at this, these are the techniques used to calculate the temperature. If you look at the final uh, point, that is, this is the upper fixed point of all the scales, that is 212. It is 100 degrees Celsius of the steam, boiling point of the water, the steam. This is 373 in case of Kelvin. And if you look at the lower fixed point is 0 degree 0 Kelvin, minus 273 Kelvin in Celsius, and minus 460 degree Fahrenheit in case of Fahrenheit, the lower fixed point. So these are the comparison of different temperature scales with one another. Equally, all in all the cases, you see that the temperature is converted. If you look at, this is the value. If you look at this one is the lower freezing point, lower freezing point. This one is the boiling point, and the boiling point the steam. Here it is 32 and boiling point is 212. Here it is 0 lower fixed point, its boiling point is 100. At the same time, the lower fixed point is 273 Kelvin in case of Kelvin scale, and the upper is 373 Kelvin. So up to this point, you see that this is the lower fixed point and the upper fixed point in this area. This is a beautiful comparison of one temperature with the other. Moon and its cold, coldest and absolute. These are the different. Okay, conversion of Celsius to Fahrenheit. Suppose this is the temperature Fahrenheit and this is the Celsius temperature. You will put the value of Celsius here and you will simply simplify and you will be getting temperature in Fahrenheit. PF means Fahrenheit temperature. You can also write like F and degree over F. So this is basically Fahrenheit. And then to calculate the temperature in Kelvin, you see how much temperature in Kelvin will be, because there is a formula. Celsius is equal to Kelvin is 70 Celsius plus 273. So this is the formula used to calculate or convert one type of the scale into another type of the scale. You know the value of one temperature. If your body temperature is 37 degrees Celsius, you will put the value of 37 here. And simple mathematical step, you will come to know what's the value of temperature in Fahrenheit. And your temperature, body temperature in Fahrenheit, a healthy person will be 98.6 degree Fahrenheit. So with this, today our class ends. I hope you people have understood today's topic. What we have discussed during this class, we have discussed three types of scales of measurement. We have compared these three types of measuring instruments together, and we have seen what's the lower fixed point and what's the upper fixed point for all types of the scales. And then we have learned how to apply the basic mathematical formulas to convert one type of the temperature scale into another type of the temperature scale. I hope you people have understood this topic. I thank you all for your patience.